I'm Richard C., and I'm a math tutor here at Wyzant, answering a question submitted by a student. This is one that's might seem kind of obscure to you, and it is sort of obscure, except that it shows up on the standardized tests. So it'll show up in school, but also on standardized tests. So it's something that you probably want to get pretty good at least in my opinion. And it really revolves around complementary angles. And I'll show you that. We're going to explore these two things. This is basically in the first quadrant. This is in the fourth quadrant. And I'll show you how this works. So in the first quadrant, we have an angle X. Now, because these two angles have to add up to pi over 2, we could call that angle pi over 2 minus x. And we'll call this ABC here. And now you can see that the sine of x is equal to b over c. You can also see that that's the cosine of pi over 2 minus x, because the cosine of this angle is adjacent over hypotenuse. This is all just SOHCAHTOA. The sine of x is opposite over hypotenuse. And we can say that the cosine of x, which is a over c, is equal to the sine of x pi over 2 minus x. And that's because the sine of pi over 2 minus x is a over c, opposite over hypotenuse. And lastly, I'll just do tangent. And you can spend a lot of time on this with the cofunction, the secant, cosecant, so on. The tangent of x is b over a, opposite over adjacent, and this is going to be equal to the cotangent of pi minus 2 minus x. Because you can see the cotangent here would be b over a as well, adjacent over hypotenuse. So this gets you into the reciprocal functions, and then you can do similar things with the reciprocals if you want to. Now, the student's also asking about this one, and this one is in the fourth quadrant. Let me show you why. So instead of writing x minus pi over 2, I'm just going to write it as negative pi over 2 plus x. So what that means, the reason that this is useful is you want to go down pi over 2, because here's negative pi over 2. Then you want to add back x. So x actually lies here. And going back to my right triangle, that's x. This is going to be pi over 2 minus x. I'm sorry, it's going to be, I have the sign wrong there, S-I-G-N. Let me go back and fix that. So if I go down negative pi over 2, I'm here. If I add x back up to it, you see I'm here. This angle is x. We're adding x back, you see. So this is what we're after, pi over 2 minus x. And of course, because this is a right angle here, this is x. So hopefully that helps you set this up. And we can do ABC again. And they're interested in the cosine and so on. So the sine of x is going to be, you just look here, opposite over adjacent. So it's A over C. And you can see that that's the same as the cosine pi over 2 minus x. And then the cosine of x is going to be the b over c, which is going to be the sine pi over 2 minus x. And then the tangent of x is going to be a over b, which will be the cotangent of pi over 2 minus x, using the same logic that we used previously when we were in the first quadrant. So you can go on and on and on with these complementary angles have these special qualities, and rightly or wrongly, I tend to see a lot of this on the SAT. I don't remember seeing it a lot on the ACT, but you'll see it in school. Some schools spend a lot of time on this, and some schools don't. So it's a good question. And you can move around to any quadrant you want, and you can find all sorts of relationships between complementary angles. So I've given you 6 here, but you can work on a lot more on your own. The key is to make a nice diagram that fits the situation, that enables you to create a right triangle and find these at will, basically. I think it's a pain in the neck to have to memorize all of these, but it's up to you. Okay, that's it for this lesson. I'll see you again next time. Bye-bye.